Hello everyone, welcome to VTU AIML lab session. In this session, we'll be discussing the first lab program, that is implementation of A-star search algorithm. A-star search algorithm, it is a simple and efficient search algorithm. It is used to find the optimal path between two nodes in a graph. So this is the program for implementing the A-star search algorithm. So we have a function here that is A star algo. So here we are passing two nodes of a graph, that is A and J, where A is the start node and J is the stop node, that is end node. And we have defined a dictionary for the graph, which consists of a node and its neighboring nodes with the distance between the two nodes. So for here we have node A, and B and F are the adjacent nodes for A. The distance between A and B is 6, and the distance between the A and F is 3. So all remaining nodes are defined in the same way. So we have a function, that is heuristic function. So for each node in the graph, we have a heuristic value assigned to it. Since J is the end node in the graph, it is assigned with the heuristic value 0. So for each node n, this function will return the heuristic value, the particular node's heuristic value. So when this function is called, we have a definition for this function here, defined here. So this start node variable will receive the value passed in this function, and the stop node will receive the value j. Next, we are initializing the variables. So here we are performing the initialization here. So open set, it is assigned to the unexplored nodes. Initially, we are assigning the start node since it is unexplored right now. So next we have a close set variable, and it is for holding the explored set of nodes. And then this stores the distance from starting node. And we have parents. So it is for storing the path. Next we are initializing the g of start node to 0, and then parents of start node is equal to start node now. So next we have a while loop. So in this while loop, this len of open set greater than 0. So it means that the open set should have at least one element. Then only this the code within this while loop gets executed. Now initially we are assigning none to node n. Then here for we represent here we in this for loop statement, we represents a node in open set. So for each node in open set, if n is equal to none, so initially it will be none. Then if n is equal to none, then we need to initialize it to v. So initially this v will be the start node. Otherwise, in later iterations, this statement will get executed. So this comparison will be done. So this is the basic formula of A star search algorithm. Next, if n is equal to stop node or graph nodes of n is equal to none, then it is just passed. So next it moves on to the else part. So if n is not, if n is equal to stop node, then only this statement gets executed. Otherwise, it will execute the statements in the else part. So this, in this statement, for m is equal to wait in get neighbors, for m comma wait in get neighbors of n. So here we are using the get neighbors function, where this function is used to return the neighbors of the node which we pass to this function. So if node m is not in open set and not in closed set, then these three statements gets executed, where here we initialize, um, we add m to the open set and initialize the parents of m to n, and g of m is equal to g of n plus wait. We perform this operation. Otherwise, this piece of code gets executed. Here, so for each node m, we compare its distance from the start node. So from start node to node through node n, we perform this operation. That is, we compare g of m with the g of n plus its weight. If it is true, then we update the value of g of m, and then we change the parent of m to n. If m in closed set, here, if m is in node m is in closed set, then we need to remove and add it to the open set. So using these two statements, we perform that operation. Next, if n is equal to then in none, we need to print path doesn't exist. So in the next statement, if the current node is the stop node, then we begin construction. We begin the construction of the path from it to the start node. So using these statements, we perform that operation. So this is the path reverse function. Then finally we print the path and return it. So next we have we need this remove open set dot remove function. So here we remove node n from the open list and add it to the closed list because all of its neighbors were inspected. So next we print that path doesn't exist if there is no path from one node to another, and return none. Then this is the definition of the uh, get neighbor function. So it will just return the value of the particular node that we passed to this function. Otherwise, it will return none. So this is the output for this program. So the path from A to J is A to F. This is the shortest path. So we have path from A to F, then F to G, and G to I, and I to J. Thank you.